Yes, in the time table നിങ്ങൾക്ക് അറിയാമെന്ന് വിചാരിക്കുന്നു. അപ്പോൾ എല്ലാവരും പെട്ടെന്ന് ജോയിൻ ചെയ്യാൻ പറയണം.
സർ അവർക്ക് എല്ലാവർക്കും നെറ്റ് ഇഷ്യൂ ആണ്.
എന്താ കേട്ടില്ല, ഒന്നുകൂടെ പറയാം.
സർ കുറെ ആൾക്കാർക്ക് VIന്റെ നെറ്റ് ഇഷ്യൂ ആയിട്ട് ഗ്രൂപ്പിൽ മെസ്സേജ് അയക്കുന്നുണ്ട്.
ഓ അത് ശരി. ഓക്കെ ഓക്കെ ഓക്കെ. സെക്കൻഡ്. ഓ കുറേ പേരുണ്ടല്ലേ. സാറില്ല, കുഴപ്പമില്ല. ഓക്കെ, സോ ഡയഗ്രാം വരച്ചു കഴിഞ്ഞോ? യെസ്, കഴിഞ്ഞില്ലേ? Please respond.
Yes, sir.
We'll see. So the topic for today is actually your wind turbine. Okay, so we have seen we have already seen the very basic things like types of turbines and all. And last class we have also covered the topic related to wind power. Wind power derivation complete. Right. So we have seen what available energy is. Okay, so let me quickly give you a recap of what we have learned actually. So we have seen here that your power, that the power of wind. Okay, so due to the power, wind density is actually given by this equation, which is Pw is equal to K into Uw whole cube, where Uw is actually the velocity of the wind. Okay, I'm going to represent it, velocity of wind. Okay, now, and that too in kilometer per hour. Okay, so that is given in kilometer per hour. Right. But the thing is, actually, the total, even though the wind has the capability to produce this much power, this entire power cannot be utilized properly, right? So this PW power cannot be completely utilized to convert it into electricity, right? So as per Gilbert's experiments and analysis, he have found that out of this, only a fraction, which is 16 out of a fraction, which, uh, okay, fraction which is 16 out of 27. Okay, only 16 out of 27, which is 0.5926 of the power of the wind is only recoverable. Right, that means only 59.2 percentage of power generated by the wind. Okay, is only recoverable. Right, 59 percentage is only recoverable. That means around 41 percentage is wastage. Okay, so it cannot be utilized. Okay, only this much amount can be utilized. Okay, and that limit is actually called the Gilbert's limit or the Betz coefficient. Right, I hope it is clear for you. Right, right.
Yes, sir.
Yes, sir.
Okay, now we have further seen that out of this 59.2, around out of this 59.2 percentage which is available, right, available, or which can be converted into power, actually from that also around 70 percentage is going as loss. Okay, so as a sum total you will be getting only 40 to 45 percentage of the wind energy is only convertible, right? And this loss is happening due to the aerodynamic efficiency of the wind turbine. Okay, so the entire the wind cannot be that is getting incident on the turbine blades cannot be converted completely. Some part of it, that is around 30 percentage, will be lost because of the uh, aerodynamic efficiency, right? Now, and finally you will be getting only 40 to 45 percent of the wind energy is only convertible. And uh, and we have seen how to find out the available energy, and we have also seen the derivation involved in this. Okay, so I hope it's here. Sorry, the derivation is not here. Right. So, one second, let me check. Okay, so we have already seen the derivation in last class. Okay, I hope you have written down the things as well. Okay, so we have seen that the available energy PA is equal to half into mv square, which is actually, sorry, not the power, which is the kinetic energy is actually half into mv square, right? And we have converted this properly, and by converting mass in terms of density and volume, and doing the further conversions, we have found that your total available energy PA is actually equal to PA is equal to 1 by 2 into density into uh, area into V cube. Am I right?
Yes, sir.
Right. And if you convert this one, you will get this final equation, this equation. That is, if you convert the area into pi by 4 d square. Okay, so this PA is equal to 1 by 2 into rho into pi by 4 into diameter d. നമ്മൾ പിന്നെ വിൻഡിന്റെ ആ ഒരു കോളം എടുക്കുകയാണെങ്കിൽ ഓക്കെ ഡി സ്ക്വയർ ഇൻറ്റു വി ക്യൂബ് എന്നുള്ള ഫോമിൽ വരും. So if you solve this, you will get it as pi by 8 into rho d square v cube of the formula. Okay, so this is the final available energy. So therefore, it actually depends upon the density of air. The available power depends upon the density of air and the diameter. That means if you consider this as the wind turbine, okay, so this is the D, small d. Okay, so it depends on this diameter and also the velocity with which the wind is getting incident on this one. Okay, and the velocity. So these are the factors which affect. So if you want to increase the available power, you either you have to increase the velocity. Uh, Either you have to do something to increase the velocity, or you can increase this this diameter. Okay, but again there are practical difficulties when it comes to the diameter of the spindle, right? Fine, so these are the basic things which we have seen, and now we'll move on to, after seeing all these basic necessities, we'll move on to the actual wind turbine. Okay, so this is how your wind turbine looks like. Okay, so we'll see, first of all, see what are the basic terminologies related to a wind turbine. Okay, So you can see this is the rotor diameter which we have represented as small d. Okay, so the rotor, so the rotating part is called the rotor. So the diameter of the rotor is considered from one end of the blade to the opposite end. Okay, so this entire distance is the rotor diameter which is represented by the small letter d as we have represented in the derivation. Okay, now then there are other terminologies as well. So you can see that you have a brake system plus there is a gearbox plus a generator, and this entire system is enclosed in a system called a nacelle. Okay, so nacelle is actually you can wrote it, make a note of this one. Nacelle is actually a housing in which it is a housing in which gears, generators, generators, bearings and control gears are mounted. Bearings and control gears are mounted. Okay, so that is called a nacelle. Okay, so you can see inside this arrangement, you can see the gearbox, gear arrangement, and then the generator is also directly connected to this setup. Okay, right. Now the next important thing is then there is a tubular tower. This entire setup is kept over the tubular tower, and the complete setup is actually held with a strong foundation. And you can see this foundation something like this. Okay, and finally, this power is actually stored and then transferred to the substation. Okay, or for local use also, it is directly used for some applications. Right. Now, additional to these things, you have certain other terminologies as well, which is related to the different controls of the wind turbine. Okay, so you may please make a note of this one as well, and after that we'll have a discussion on this. Okay, so it is controls of the wind turbine. So before that, we have seen what are the basic components of a wind turbine, right? So these are all basic components, and then to get the maximum output from the wind turbine, you need to control. For example, നമ്മൾ വിൻഡ് വരുന്ന സമയത്താണെങ്കിൽ നമുക്ക് മാക്സിമം വിൻഡ് യൂട്ടിലൈസ് ചെയ്യണം അല്ലെ. So the blade should be oriented in such a way that it gets the maximum wind, and and the blades are rotated as fast as it can, right? So that is one parameter. So to increase the rotation or the rotor speed, there are certain things that you can do. Okay, there are different arrangements or the different control systems that you can implement on the system. For example, to get the maximum wind, if the wind is coming from this direction, to get the maximum wind, the orientation or to uh, utilize the maximum wind energy, the orientation of the wind turbine blade should be in such a way that it gets the maximum output, right? So the control of this wind blade is one thing. Similarly, if the wind direction is in some other opposite direction, you need to rotate this base arrangement so that you will get the you can utilize wind the maximum wind that is coming from the other direction as well. Okay, so for all these purpose, we need different control systems, and this control system, it is very important topic, and these are the main three control systems in a wind turbine. That is pitch control, yaw control, and tether control. Okay, so please make a note of this diagram. After that we will have a discussion. Okay, clear അല്ലേ? Correct. Right.
Yes, sir.
പെട്ടെന്ന് വെച്ചോ. Yes, note ചെയ്തോ കഴിഞ്ഞോ? Yes.
ഇല്ല സാർ വരക്കുന്ന
Okay. Just speed ആയിക്കോ. അല്ലേ കഴിഞ്ഞില്ലേ?
സാർ
Okay. So, so this is very important. These are the three different control systems. Okay. So I'll show you what are those. Okay. So ഇത് കോമൺ ആണ്. പിച്ച് കൺട്രോൾ ആൻഡ് യോ കൺട്രോൾ നമ്മൾ പല ആപ്ലിക്കേഷൻസിലും കാണുന്നത്. ഫോർ എക്സാമ്പിൾ ഈ ഒരു ഡ്രോണിന്റെ ആപ്ലിക്കേഷൻ ആയാലും അതിന്റെ പിച്ച് കൺട്രോളും യോ കൺട്രോളും അതിന് വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്. ഓക്കെ. Now, so we'll see what are those. So pitch control. So before going to pitch control, you should know what a pitch is in terms of your wind turbine blades. Okay, so you may note this one. So pitch angle. Okay, so pitch angle is actually, so this is important. ബാക്കിയുള്ള നമ്മൾ normal സാധനങ്ങളാണ്. So pitch angle is actually the angle between the direction of wind and the direction perpendicular to the plane of the blades. Okay, so for example, if this is your blade, okay, suppose this is your blade. Okay, so and wind is blowing in this direction. Okay, so for example, let the wind be blowing in this direction. Okay, and then the pitch angle is actually defined as, and let the normal to the blade. Okay, this is the normal to the blade. Okay, then the pitch angle is actually defined as the angle between these two. Okay, the angle between the direction of wind and the normal to the blade. Okay, so this is your blade, and the angle that is made by the normal of the blade to the wind direction, that is called the pitch angle. Okay, so this pitch angle is very important because if you have an optimum pitch angle, it can utilize the maximum wind. Okay, so so the pitch control is important. So the pitch control is actually the controlling of this thing. Okay, so it is actually the tilting of this blade is possible. Okay, you can see this and this kind of a movement for the for the blade is called a pitch control. This to and fro motion for this one. Okay, so that it can utilize the maximum wind. Okay, so this motion given to the blade is called a pitch control. Okay, so you may note this one. Pitch control, it is used to control the pitch angle by tilting the blades or blade tips. Okay, used to control the pitch angle by tilting the blades or blade tips. The purpose of pitch control is to maintain the optimum blade angle. Okay, optimum blade angle in the sense it utilizes the maximum uh, wind so that it gives the maximum rotor speed. Okay, and the maximum power output. Fine. So this is the pitch control, and the second one is actually your yaw control. Okay, so yaw. Uh, Sometimes, for example, let us consider a wind turbine, something like this. Okay, okay, something like this. Okay, so if suppose during the morning the wind is flowing in this direction, and in the around some afternoon and all, the wind is flowing in the opposite direction. Okay, in some direction, something like this. So in this case, if it is a fixed system, the thing is it can only utilize the wind that is coming in the morning time, right? So the yaw control is actually with the yaw control, it is actually possible to rotate this system to this direction so that at the time this setup will be something like this, so that it gets oriented in this direction. Fine. So your control is actually the rotation in this direction. So this one actually represents the your control. Okay. So you can note this one. Your control is actually used to control the orientation of axis of wind turbine in the direction of wind. Okay. So you can note this one. Used to control the orientation of axis of wind turbine in the axis of wind. Okay. And this is important. Your control ensures that the turbines are constantly facing into the wind to maximize the effective rotor area and as a result power. Okay, so that point is very important. Right, totally. Yes.
ആ സർ.
Okay. So the next one is actually your third motion, which is your tether control. Okay. So that is this one. So it is actually this motion. As you can see, this motion. Look at this tilting motion, which can be given to the wind turbine. Actually, I'm gonna on the mode like okay. So that so as to maximize the output. Okay. So that is actually a tether control. I hope you have drawn this one. So you may note the things as well. Okay, so tethering it's actually it's a seesaw-like motion. Okay, so up and fro motion. So seesaw-like motion between the two alternatives. Okay, the plane of the wind turbine wheel is swung in inclined position at higher wind speed. Okay, tethering control. Okay, okay, so fine. So these are the basic control systems for a turbine. So we have seen, so in today's class we have already seen turbine, basic turbine structure, okay, structure and the different control systems, different control systems for a wind turbine. Okay. So tomorrow we'll see the basic functioning and uh, then the hybrid system of solar and wind power. Okay. Okay, so that's it. Thank you. Okay, any issue?
Okay, sir.
So, veterans,